Traveling to Consciousness, exploring spiritual journeys to find answers in uncertainty.
What is up, conscious monkeys? Welcome back to another episode of Traveling to Consciousness. As always, I'm your host, Clayton Cuteri. And in today's podcast, we're going to get into my energy policies. We are going to discuss energy because, well, first of all, energy is basically the building block of life, right? Everything's energy, everything's matter. But from a political perspective, it's so important that we actually discuss this because to me, the more that I've done research into energy, it might be one of the biggest issues that are not being addressed in the world today. And America specifically, but the world as a whole. Like, our energy infrastructure is tragic, to say the least. And even more concerning, to me at least, is the way that maybe some of the leadership and the elites look at energy. Because I've even heard very well-known people, I'm not going to go into specifics, I don't want to call anyone out, haven't done research, but well-known people speaking highly of certain energy models that are very disastrous. And in particular, nuclear energy. Like, I think that there's some sort of guise going on around nuclear energy of how it's going to be our savior, and it is far, 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 far from it. And specifically, that's the style of energy that I've been hearing from, honestly, very intelligent individuals within the technology space, but yet they think that this is going to be a big solution, and it is not. It is a complete farce. And we'll get into that. I'm going to get into you to tell you like why this is a huge issue. And then we're going to jump into my proposals of how we can actually fix this and how we can approach this in a very healthy way. And even more so, protect the planet as a whole as we go through this. So let's jump into it because I think there's been a lot of bad information out there, is what I'll just assume, that there's bad information. Who knows for sure if people are, wise or what's or whatever. But let's jump into it. Starting off with one thing that never gets really any media attention, but is AI. So deep learning neural networks, the computational process that goes into creating them is extremely intensive, very intensive. As an example, in 2023, data centers were estimated to be about 1 to 1.5% of all global electricity, which is absolutely insane how much electricity that is. And I couldn't find too much data. I found some data, but I found this one in particular of how, like, the direction, right, that everything's going. So over 1.5 billion servers are being planned to ship by 2027, right? So this is projection. This is where we're headed as a society. Planned to be shipped by 2027, which will be at least at the very minimum, we're underestimating here, will be at least 85.4 terawatt hours per year. Now, what in the world is a terawatt hour per year? How can we even measure that? What, like, is that a lot? Is that a little? Let's put it in perspective. So for comparison, a standard U.S. household consumes about 10,000 kilowatt hours per year of electricity per year. So if you have 85.4 terawatt hours of electricity, which is what AI will be at least in 2027, that is about 8.54 million homes for an entire year. So think about that. Just in AI, we need to produce electricity for another 8.5 million homes. And I'm going to put the link down below. This is a podcast that is going to be heavily link orientated because I think when we talk about energy, we talk about money. I think this is stuff that you need the data. You need the numbers to like look at yourself and honestly to validate, because I think with a lot of these things you get into some nuances, but and as you're going to see as we go along, I found other numbers, and so I'm going to be very clear whenever we're talking about household income or household electricity as we move forward. But I just want to be very thorough, right? So we're going to give you your sources down below. But this, let's get back to it, right? We're talking about 8.5 million more homes in an entire year that we have to power, and that's just AI. So the point, I guess the whole point of this, right, is just to put forth that it's an issue. Energy is an issue that we need to address, because if we do not increase the supply and we increase demand, prices go up. And I think we all know that that's a terrible idea, right? Another disconcerting fact is that only 12% of U.S. energy currently is renewable. That was done by a study at the University of Michigan. Put the link below. But only 12% of U.S. energy is renewable. We obviously have to get that number up, operating costs. And if we were to even double our nuclear energy output by 2050, we would only reduce the greenhouse gas emissions by 4%. And not to mention the cost that would go into that, not to mention the lack of energy that's truly being created. I mean, there is a lot of energy that gets created from it, but you run into other issues, which includes, and this is honestly my biggest proponent, which is the type of waste that it produces. So a common argument that you'll usually hear whenever it comes to nuclear energy is that it's not wasting a lot. It doesn't create a lot of byproduct or waste. What they don't talk about is the harm that that waste can produce. So again, being a spiritual individual, being someone who's concerned about the future, being someone who's centered, leading from the heart, cares about the future generations, we have to look at the long-term effects of our solutions. We have to stop with, oh, it works for now, we'll address it later in the future, because that's just not, it's like that blueprint. That blueprint is what we've been modeling our entire society around for so long, and look where it's gotten us. So it's time to stop that mindset, and we need to start looking hundreds of years in the future. I mean, and even just to sit on this idea for a second. I didn't realize I was going to go down this rabbit hole, but to sit on this idea for a second. Buildings are now in America, and you can see these everywhere, are built to get up in, 5-10 years, maybe 15 years if the construction gets delayed. Yet, if you go to Europe and look at these buildings, some of the most beautiful architecture we've ever seen, they had visions of 500, 600, 700 years to build these beautiful pieces of architecture. And it has been tremendous input for their economy. It has had a tremendous benefit to their countries, because people flock to see these amazing pieces of art and architecture. And so I'm just saying that, there's so many benefits to having a more long-term view of the world, to realize that, we only live 100, maybe 120 years. Maybe we'll have 200 years by the time, we get there. But the key is that even if you live 200, 300 years, whatever it is, there's going to be a civilians that live after that. So we have to think about them. We have to think about the next generation. We have to think about however many generations back or forward that we can, because those are where powerful ideas will come from. And so I go down this tangent because the waste, bringing this back to nuclear energy, right? The common argument is that it doesn't produce a lot of waste, but the waste that it does produce is believed to be an issue and pose challenges for up to 1 million years. Think about that, 1 million years. I believe that's roughly what our current timeline is of Neanderthals being on the planet. It was 1 million years ago. Could you imagine Neanderthals if they would have just kind of started just going down the path of nuclear energy, and then by the time it got to us, we would be deformed creatures, if anything. We would be wiped out. It would be just absolute polluted earth everywhere. We would be in so much trouble. Again, I'm going to post a link to this article as well. And so even here, right, even in this article, here's a quote. These periods are so mind-bogglingly long. There's also such mind-bogglingly. I know the word. I know I've said bogglingly. I know I've said this word before, but it feels weird reading it out loud. Mind-boggling. bogglingly. That feels weird. They should not have wrote that word there. That back in 1981, the U.S. Department of Energy established the Human Interference Task Force to devise ways to warn future generations of the dangerous contents of nuclear repositories. So our government, the Department of Energy, decided, hey, these are going to be such issues in the future that we actually need to dedicate resources, time, and money and effort into telling future generations. Is that not just insane? Does anyone else just hear that and think like this is absolute insanity, that we're actually going to take an approach that is going to have such bad long-term effects that we're just going to develop a sector of the Department of Energy to say, hey, we're going to create this human interference task force so that they can warn the future generations. We're not going to worry about it. We'll just warn them of like what's going on in the nuclear repositories. So how long is like the plan for this? There's no plan for nuclear energy. It's a very, very bad idea. And the perfect example of this, as a matter of fact, there is a very good case study of this. Maybe you've heard on March 11th, 2011. Do you remember that date? The Fukushima nuclear accident, which happened at, and I'm going to botch this, but Fukushima Daiichi nuclear power plant in Japan. It is one of the most significant nuclear disasters in human history. Well, in our known history. Second only to Chernobyl disaster of 1986. I know you've heard of Chernobyl. A little bit different scenario, but nonetheless, still tragic instances. Now, Fukushima, it was triggered by Mother Nature. It was triggered by a massive 9.0 magnitude earthquake called Tohoku, and the resulting tsunami, which struck the plant and led to catastrophic failure in the plant's cooling systems. This accident led to the evacuation of over 164,000 residents from the surrounding area due to radiation risks. Again, poisoning the planet. We have to stop that. So if one of these things go, not only is it going to dislocate people, is that the phrase? Not only is it going to move people out of their homes, but it's also going to poison the home that we all share of Mother Earth. Now, they state here that while there were no immediate deaths from the radiation, the evacuation process itself actually caused, they estimate, 1,700 deaths. And this is primarily due to the stress and other health complications among elderly population and trying to relocate that many people. So imagine you have an area that's even more populated than what Fukushima was. I mean, you're dealing with huge issues here. And they even go on to talk about the long-term environmental and health impacts of the released radiation that are still being studied to this day. Now, they say that although there has been no significant increase in radiation-related illnesses among the local population to date, but I would challenge that. I don't know that I could fully believe that because, and here it goes into hypotheticals, I don't know for sure, but the radiation gets into the ground. The ground is where we grow our food. It's where we keep our water supply. I have a hard time believing that there was no radiation-related illnesses. I'm sure you could find some stuff from 2011. I'm sure there's data out there now that the areas that radiation would have touched. I mean, I'm pretty sure there was issues with California because it was getting into the water, and the water's going to just spread it throughout. It's not good, guys. It's really not good. And then on top of that, remember, this was 2011. So right now we're in 2024. So this was 13 years ago. 13 years ago. The cleanup and decommissioning of the Fukushima site is an ongoing process expected to take several decades. Efforts have included the removal of spent fuel rods from the damaged reactors, containment of radioactive water, and decontamination of affected areas. The Japanese government has also involved in extensive compensation and recovery efforts for the displaced populations. As of today, Fukushima remains a site of ongoing concern, particularly regarding the management of radioactive water stored at the plant. Surprise, surprise, which will take 1,000,000 years unless we can somehow figure out how to get fungus and mushrooms to decompose radioactive material super quickly. That's beside the point. But the Japanese government has proposed releasing the water into the Pacific Ocean. Oh, it just gets better and better. After treatment, of course, they'll treat the water and then they'll release it. And of course, this has been met with international criticism. I mean, guys, this is out of control, right? And now, okay, I'm looking at the time on the podcast. I know I don't normally go this long, but so far we've just been talking about the negatives, and I'll kind of just brush through this a little quicker because I know we keep these podcasts a little bit shorter. This would be good for a more in-depth one. I'm getting sidetracked. I think it's very important that we really address that nuclear energy is not the way forward. The number of issues, the amount of the length that the pollution stays on the earth, and the power of that pollution, right? Is like, I think they should probably do some sort of scaling model where it's like, the amount of issues, right? Like if you're introduced to, like, if you drink a cup of radioactive water versus, putting a couple tons of CO2 in the air, right? Like, I have to feel like the cup of water is going to be a lot worse, So I don't know how you exactly monitor that. I'm dragging this on a little bit. So let's move on to the next part, which is actually, speaking of waste, energy waste. So our current infrastructure is extremely inefficient. So we definitely need to put resources into understanding this more. So our current energy infrastructure wastes about 66% of energy from its source to the consumer. So I'm going to put a link in the description below so you can look at a much more detailed, in-depth understanding of this. But essentially, you go from your primary source, say it's like coal or something, then you have to mine it out of the ground, then you have to distribute it. You have to somehow distribute that coal, that energy that you're sending, right? Then once it's sent, you have the wiring and devices. So say like you have electrical wires and whatnot, you're going to lose energy just from the transfer of the energy through the wires. And then at the end of that whole process, you have the useful energy, which is powering your lights, is powering your phone. But 66, from digging up that piece of coal, whatever it is, to getting to your phone, we waste 66%. So surprise, surprise, we waste more. Another thing that's actually very fascinating, and I don't have the time to go too deep into, is the history of technological and innovative suppression. Anyone who knows the history of Nikola Tesla, perfect example of technological suppression. But more so, in 1951, there was a Technology Secrecy Act, and the point of it is, hey, if some sort of technology comes about that threatens the quote unquote threatens the national security of the nation, then it can be banned. And I've made TikToks on this, but every single time I make a TikTok talking about the Invention Secrecy Act of 1951, it always gets like demonetized and blocked very quickly. So, ask yourself why that might be. The source that I'm going to put down in the show notes is that in 1971, they actually released a patent list on restrictions for different things that were like confiscated. These included power conversion units and solar panels. So back in 1971, they had solar panels that were over 80% efficient. So that means if you have like a solar panel laying out, it can collect over 80% of the energy of the sun that hits that solar panel. However, they made this illegal. Right now, if you look for solar panels, you're going to find them between 20 and 25% efficiency ratings. They don't allow anything higher than that. It's essentially illegal. And so I don't think solar panels are the answer either, because in order to use solar panels, you have to put them on, the ground, and you're basically taking up space for grass to grow, for trees, for wildlife, for vegetation. So, and then even if you look in Texas, I think this happened a few months ago, They had a hailstorm, broke the solar panels. Solar panels then leaked toxic, cancer-causing agents into the ground. You can't make this stuff up, people. You can't make this stuff up. So, big picture, I mean, if you have solar panels, I think good for you. If they're on your roof wasn't going to be vegetating. I think we should try to get plants on our roofs. Big picture, that's what I would vote for. But small picture, I think, if you're using solar panels, get those tax rebates, but I don't think it's a good big term solution. So let's move on. I feel like I've been negative for the first 21 minutes of this podcast. Let's get into the technologies that could actually work, right? Because it's been a very doom and gloom scenario here. But here's the thing, is that I have good news for you, okay? And this is going to start, if you look in the links, with PavGen. So PavGen is a technology that they're creating that generates electricity from footsteps. So if you don't have time, if you're operating machinery, don't have to look at the video right now. But essentially what it is they put a little panel on the ground, and below that panel is like a little, maybe like 1-inch button, if you will. And so as you walk, that button gets pressed and the panel gets pushed back up. So every step will generate a little bit of electricity. Any of my Rick and Morty fans out there who know about like the stepper in the episode where Rick goes into the lower dimension and it's not the flugel crank. I forget what they called it. Flugel crank was one of the lower dimensions. But my point is that we can generate electricity from our footsteps. We can subsidize this from the government. Once the American Congress Party gets in power, once you put me in power, we can subsidize people and companies like PavGen, so we could install these throughout the ground. Actually, I should have reached out to someone on PavGen to come on the podcast. That's a great idea. I should do that. But until then, we can put these things along the ground. We can put it in places like subways, in crowded areas. So like subways, sidewalks even, if we can make them weatherproof. And we'll just be able to absorb energy through that. So we'll harness a tremendous amount of energy through those. I think a little bit more research needs to be done. They need to tighten up the costs a little bit for it to be truly economically feasible, but throw a little bit of money at it, and I think we could probably figure it out. Another great, let me see here. I have this, my notes are a little bit out of order here. Okay, yeah. So we'll come back to that one. Highways and bridges. So again, this goes into kind of like a little bit more deeper of a physics lesson and electromagnetics. No, it's not electromagnetics, but a little bit more of a physics lesson. But we can utilize highways and bridges with cars driving on them. So we can create, we can capture a lot of energy from the friction between tires and the road by capturing like the kinetic and some of the piezoelectric energy that's being generated just by driving on a road. Because right now there's a tremendous amount of energy between the wheels and the road, and it all just gets wasted. It either just goes in the ground or it'll just leave from the sides. So again, I'll throw some sources down below. Great stuff happening at Rutgers, and just like a bunch of articles just talking about the feasibility of it. Furthermore, and I think this one coming up right here, I think is probably one of the most promising ones that doesn't really get discussed. I've never really heard it discussed, probably for good reason. Well, not for good reason, for bad reasons actually, but we're going to discuss it here, which is capturing the energy of waves. That's right, ocean waves. So the Electric Power Research Institute estimates that the total wave energy resources along the United States coastline. So let me read that again. The Electric Power Research Institute estimates that the total amount of wave energy that the United States has as a resource along its coastline is at 2,640 terawatt hours per year. 2640 terawatt hours per year. So I think we kind of went over it earlier, right? About a terawatt hour per year. The measurement that I had earlier would have stated that a terawatt hour per year could supply 100,000 typical U.S. homes. Their research says that it would power about 93,000 typical U.S. homes. So They're saying essentially that U.S. homes are a little bit more costly, but but so we can say that the standard home consumes about 10,000 maybe kilowatt hours. Sorry, I'm losing my train of thought here, guys. So this project is saying that's a little bit more, but here's the deal. Okay, so if we were to achieve 100% efficiency of capturing all of those terawatt hours of coastline energy, it would supply power. Have you done the math yet? It would supply power to more than 245 million homes. 245 million homes. To put that number in perspective, and that source is down below, to put that number in perspective, in America in 2022, there were 114 million homes. Thus, we can supply energy to every home in America only using power generated by ocean waves if we only capture 58% of available energy from those waves. So I threw a lot of numbers at you there. Let's go back very slowly. The coastline, 2,600 terawatt hours on the coastline, would be able to supply power to 245 million homes, but there's only 114 million homes in America. So we could easily supply energy to every home in America only using ocean waves. Forget everything else I told you about. The stepping on the floor, the highways, the bridges. We could do it all just from ocean waves. And then on top of that, we bring AI back into the mix, right? It needs 85 terawatt hours per year, which is about 8 million homes, right? So if we just add 8 million, we would need to capture about 65% of available energy, 65 to 70% of available energy from ocean waves for AI and for all the homes in America. And you don't have to poison any water. No poisoning of water. No poisoning of land. Isn't that amazing? There's an amazing solution right in front of us. And now this will take time. Don't get me wrong, this will take time to implement, to create. And so another piece of our policies, and this is honestly, maybe I should have led with this, is that we will subsidize, the American government should subsidize somewhere between 50% and 75% of the electricity costs for the U.S., for Americans, for citizens, for residential housing. How are we going to be able to pull this off, you might be asking? Well, we're no longer going to be spending it on our military. We're no longer going to be sending it to foreign countries. We're no longer going to be spending it on nuclear warheads. We're not going to be spending it on, what is it, like $400 nails that go to the military. Instead, we're going to be putting it back into our country, taking care of our own citizens, as the Constitution says that we should be using our money for, and that the federal government should be using our money for. Nowhere in the Constitution, at least not yet. I have not found it. I'm still looking. But nowhere in the Constitution does it say that we should be giving our money to foreign powers. So all of this being said, first of all, I appreciate you listening, but all this being said, let's do a quick overview, right? We have AI on the rise, which is going to be generating a tremendous amount of electricity. Nuclear energy is to me, it's honestly a non-starter. I don't understand what the love obsession is, especially with very intelligent people. I'll be honest. I know there's intelligent people. I strongly disagree with them on this. Extremely high operating costs, extremely expensive to get going. The waste, of course. Okay. I agree that, the amount of pollution is less, but the potency of that emission is so tremendous that it would take over 1 million years for it to, for nature to take care of it. Now, if I'm being honest, you guys have listened to this point in the podcast, so you deserve a little bit extra honesty. 1 million years is what they're saying. I personally think Mother Nature is very intelligent, very smart. So I personally think that number's probably a lot less. Like, I think Mother Nature will be able to clean it out a lot quicker. But even if that number's halved, that's still 500,000 years, guys. Like, and I mean, let's say Mother Nature is out of control efficient, and it's 10 times more like efficient than what we think it is. That's still 100,000 years. It's a non-starter to me, guys. We also have the U.S. Department of Energy trying to educate future generations about not going near nuclear repositories. So why are we even entertaining this idea? Currently, we waste a ton of energy just to get it to the end user. We have technological suppression going on. And then the beauty, the beautiful utopia, maybe not utopia, but the beautiful future that we could have as a one people, right? Of this technology that, where the floors, basically you can step on floors to create electricity. We have highways and bridges that could capture some kinetic and piezoelectric energy. We have the, sorry, got like cut out there for a sec. We have the waves capturing the wave energy, which I think is just, could have probably just made a whole podcast on that and been like, okay, this is the fix. Yeah, and then subsidizing. I mean, I think, and my viewpoint is stop trying to just give people their money back. Like, the government wants to collect money and give it back to people. I say instead just leave it in people's hands, So by us reducing the cost of electricity, you don't need to make more money, right? We'll just spend it on reducing electricity costs. The government will pay for that for family homes, right? For single family homes specifically, but family homes in general. We'll subsidize 50 to 75% of the electricity costs that people have to spend because they're getting out of control. They're getting astronomical. And we'll do this by relocating military spending because we're not going to have any wars. We're not funding foreign governments anymore. Yeah, so I think the state of the country, the state of our leadership is taking us in a very bad direction. Very dark. I think it's very misinformed, very uneducated. And what the beauty is that I'm here, that the American Congress Party is here, and that we have a beautiful solution to get us from where we are to a more holistic, a more nature-orientated, a more loving, a more clean, a more pure way of living. So I hope you can see that as well. And I also hope that you guys can share this podcast as well, because I put a lot of effort into these things. And I'm not trying to guilt trip you, but if it gets you to share the podcast, then maybe I should guilt trip you. I'm just kidding. No, I appreciate you guys listening. I really would appreciate if you shared this with someone else, because honestly, that's the best way. And they always tell you to put call to actions in these things, but just share it. Just share this podcast with someone. And quite frankly, if I'm being honest with you guys, if you don't share it with someone, then we're going to have a conversation about it whenever I see you in the 6th dimension.